Hey guys, so today I'm going to be doing a video about oscilloscopes and aliasing. So you can see here I have my function generator, and there I have my cheap little scope, and up here I have my nice analog scope. So I'm going to show you what aliasing is. You may have heard this term aliasing, like your digital scope will alias. Cheap digital scopes alias quite badly. You don't want aliasing. Watch out for aliasing. But maybe you don't know what aliasing is. Maybe you've heard of it, but you don't really understand it, or maybe it's happened to you and you didn't even know it, and then there's a problem because of it. So what is aliasing? Well, simply put, aliasing is the act of undersampling a waveform. Okay? And now, digital scopes are not prone to this for a reason, is because analog scopes are not prone to this because analog scopes sample effectively super fast. That you don't have to worry about analog scopes aliasing. It really doesn't happen unless you're in the super $1 million scope range that nobody watching my videos is in. So you don't have to worry about that for analog scopes. But you can see this is a cheap digital scope. This is about the cheapest digital scope you can buy. Don't buy it, though, because it's really bad. But I'm going to show you. You can see on the screen here, we have a waveform, and we can, if we move over to the analog scope, we can see this waveform again, okay? Both the scopes are set for the same time base, so if I can adjust my camera properly, you're going to see that if we line up the horizontal thing, we have about 1, 2, 3, 4, 5 times 20. We have about 100 microsecond period. Same thing with this scope here. We can move our horizontal position. And if we count 1, 2, 3, 4, 5, we have roughly 5 again. Okay? So that's great. Now, so we know that because our analog scope is displaying it, this is the real frequency of the waveform. This is what it really should look like. So I'm going to show you on the analog scope what happens when we turn down the time base. So we're going to turn it down. It's now at 20 microseconds per division. Now it's at 50 microseconds per division, 100 microseconds per division, 200 microseconds per division, 500 microseconds per division, 1 millisecond per division, 2 milliseconds per division, 5 milliseconds per division, 10 milliseconds per division. Keep in mind this might look weird on the camera because the camera will actually alias the screen. I'll get to that in a minute. But 10 microseconds per division, 20 microseconds per division, 50 microseconds per division, 0.1, and now 0.2 seconds, okay? So you can see that there is no... Well, you can see here is that, this is what it's going to look like at 2 milliseconds per division. Before this, you can actually visibly see the sweep across the screen. As you can see, I am triggered because if we turn down, there's our signal. But obviously, because we're going so slowly across the screen, you're not going to be able to see a signal. Okay? So now, if we look on our El Cheapo scope here, and we unhold the waveform, and we're going to go to the time base, and we're just going to switch this up. Okay, so now we're at 50 microseconds per division, 0.1 milliseconds per division, 0.2 milliseconds per division, 5 milliseconds per division. Okay, now we're at 1 millisecond per division, and you can see the scope is now aliasing very badly. Okay, aliasing means the act of undersampling something. So as you can see, that we're now at 1 millisecond per division. I'm not making this up, right? And this is the same signal, because if we go over to our scope at 1 millisecond per division, you can see it's that same signal. Okay, they're both plugged in. But oops. Okay, so but you can see this looks like it has a 2 millisecond period. Okay, so this looks like it's a 500 hertz signal, but really it's not. We know it's more like a 10 kilohertz signal. So the scope is lying to us. Okay, the screen is obviously just lying to us. See a 2 millisecond period? You can see how it lines up with a graticule. This scope is blatantly lying to us, because if we turn to the analog scope, we go to 2 microseconds per division. Obviously, this one is on hold. I don't have the trigger set because I was too lazy. But as you can see, that's clearly 2 milliseconds per division. If we pause it, 2 milliseconds per division. And if we go down to 1 millisecond, You can see that's a 2 millisecond period right there. But now if we're on, I think, 2 milliseconds here, you can see that this signal is clearly not 2 milliseconds. Or if we go down to 1 millisecond, like I just had it, clearly doesn't have a 2 millisecond period. It clearly has more like a 100 microsecond period, okay? So this scope is just lying to us, okay? This cheap digital scope is just blatantly lying to us. It's telling us that the signal is a different frequency with a different period than it actually is. Okay, so why does this happen? Why does this little scope lie to us? Clearly, when we step down the time base to the correct time base, it's clearly showing us the correct signal. So why is it lying to us? Why is that this scope is telling us that the signal has a different period? Well, that's because when this scope is on the higher time bases, it's actually undersampling the waveform, meaning it's sampling the waveform, whereas now it's sampling it, say, every pixel. So there's 100 pixels. It's sampling this waveform 100 times in 20 microseconds, right? If we turn it up to 1 millisecond, it's going to only sample the wave effectively like here at this point on the wave, and then another 100 microseconds later here. So what it's actually going to do is it's going to sample here, and then on the next cycle it may sample here, and on the next cycle here, 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 here. So on every consecutive cycle, it's going to actually build up a slower picture of the waveform. So if you follow it on this cycle, say it first samples here, right? It may hit here. It's going to hit, say, 1 pixel over on the next cycle that it samples, that it's A to D converters are sampling. So it's actually going to undersample the waveform, and it's going to build up a picture, because each time it samples, it's going to sample at a slightly later spot on the waveform, and it's going to build up a picture of the same waveform, but at a much lower frequency. And this is because it's undersampling it. It's not giving enough samples to actually build up a full picture of the waveform, whereas this does not happen on an analog scope, because the analog scope, like I said, effectively samples super fast, too fast for something like this. So as you can see, if we turn the time base, we're not going to get aliasing on this scope because it's an analog scope and it's going to sample fast enough. So that is really a major limitation of cheaper scopes like these, those pen-style scopes you can buy. Even the Rigol scopes will alias. Not quite as badly as this, but they will still alias. So that is something that you have to be wary of, is scope undersampling a waveform and then building up a picture of a lower frequency, because the scope is lying to you. That's not happening. So normally scopes will tell you exactly what's happening, assuming that you probe correctly and you don't have issues with the mains ground shorting out anything. The scope will tell you exactly what's happening, assuming you have your trigger set properly. Not the case with a digital scope. It could be aliasing. So you don't want to fall into the trap of thinking your signal, it could be many orders of magnitude lower frequency than it actually is. So if you suspect your scope might be aliasing, check on an analog scope. Or better yet, don't buy this scope at all. Check on an analog scope. Buy an analog scope like this, because it's really nice. Okay, but assuming you have a Rigol or something like that, cheap digital scope, they're still going to alias on you, but make sure that you have an analog scope to check that they're not aliasing on you. Keep in mind they can't alias on a non-repetitive waveform. This is obviously repetitive, as you can see if we turn it up, and then you see it's the same thing as we scroll across this whole sweep. So it's the exact same. It's repetitive, so they can't alias so much on non-repetitive signals, but just keep in mind aliasing, that your scope will lie to you and say it's a lower frequency. Now obviously what you can do on some scopes is turn up this sample rate so that they sample faster, and then they're not going to alias, so you're probably going to want to do that if you suspect it may be aliasing on you. If you think, hey, my signal's really, it's saying it's like 20 hertz, but really I think it's 20 kilohertz or 2 kilohertz, then check on an analog scope or increase your sample rate on your scope to make sure that it's not aliasing. So like I said before, the camera could actually alias the scope screen. What aliasing comes up in things other than scopes, like you're probably familiar with in a movie. Right, this rest of the video is probably not going to have much to do with electronics, but more to do with just aliasing in general, so that you can get a better mental idea of what's happening and just some normal examples from everyday life. So you're probably familiar with in a movie where where they're filming cars and the cars are going fast, that maybe the car wheels might spin the opposite direction. So you might be expecting them to spin forwards, but you see the wheel is really spinning backwards and probably quite slowly. And you're probably thinking, well, okay, that's weird, and you probably don't give it a second thought because you know obviously the car wheel can't be spinning backwards. So you probably just started watching the movie again and didn't give it a second thought. Well, that's because the camera is actually aliasing the wheel, as in the camera is not sampling the wheel fast enough to build up an accurate picture of it spinning forwards. So if you have your wheel spinning around and the camera is only actually taking a frame, every time it spins around plus a little extra, it's going to look like it's spinning forward real slowly. And once the wheel hits the point where it's spins around more than once and it's going to hit backwards, you're actually going to get the wheel spinning backwards. So that's because the wheels will spin backwards the opposite way you expect them to in like a car chase or something, because the camera's actually undersampling the wheel. It's basically taking a frame, it's taking a frame every time the wheel goes around, plus a little extra, or every time or every 3/4 of the time the wheel goes around. But it's not sampling the wheel fast enough. It's not taking enough frames per second fast enough to actually get the wheel going all the way around. So that's why car wheels go backwards. That's because of aliasing. That's why your scope will lie to you. That's why if we turn up the screen speed to something like this, in real life you can clearly see, if you have an analog scope, you can do the same thing, turn it up to like 5 milliseconds per division, which is 2 milliseconds, it sort of flickers a bit, and then 5 milliseconds per division, you can actually see the sweep go across in real life. It's going across pretty quickly, but you can see the sweep. But the camera, it just sort of looks like there's blocks, and that's because the camera's actually not sampling, not taking enough frames per second to actually see the sweep go fully across. So it's hitting its first frame, the sweep is here. Its next frame, the sweep could be off the screen, and the next sweep could be here, and so it's going to actually it's going to get the blocky effect. So that's why cameras can't capture, slow sweep, or this sweep speed, the fast sweep speed, very well on a scope. You can see right now it's not aliasing. Now it's aliasing, and it's still aliasing a little bit. And now it's fine because the sweep is going across so fast, nor the human eye and a camera both can't keep up with it. So that's what aliasing is. It's basically undersampling a waveform, or anything for that matter. So keep in mind when using a digital scope and an alias is on you, that can happen, that can ruin your day. So don't let it happen.